Hi, my name is Bailey, and I'm here to talk to you about my experiment called the Effects of Ocean Acidification on Clam and Crab shells. So, as the ocean becomes more acidic, many shelled organisms must work extra hard in order to create their shells, while some lose their ability to make them altogether. Because of the increased amount of energy these organisms must expend, ocean acidification oftentimes has devastating consequences on their ability to reproduce. With many ecosystems and economies dependent on the use of oysters, clams, and crabs, we cannot afford to let these creatures go extinct. So, in order to learn more about ocean acidification and test the effects of OA on different types of shells, I designed an experiment that compares clam shells and crab shells in acidic conditions. By doing this, I hope to learn whether ocean acidification really affected different shells differently, and if so, why. So, another motivation I also had for doing this experiment was based on a study that I saw that was similar to mine that I came across while doing research. So in this experiment, researchers found that most invertebrate shells deteriorated when they were exposed to increased levels of pH. However, all of the crustacean shells in the experiment actually grew stronger and heavier and benefited from OA, which I found fascinating. So this also sparked my curiosity and inspired me to recreate this experiment on my own. So the question that I had was, which type of shell is more resilient against the effects of ocean acidification, clam or crab shells? So my hypothesis was, if clam and crab shells are placed into water with an increased pH, then the crab shells will be positively affected and will have a heavier final mass, while the crab shells will be negatively affected and have a lighter final mass. So I thought my clam and crab shells would have similar results to those in the experiment that I read about. Okay, so these are my identification variables. So the independent variable was the type of shell used, so whether it was a clam or a crab shell. My dependent variable was how much each shell will have grown by looking at the initial drift final mass, and that will be measured in grams. The control group was the shell placed in seawater at a normal pH, and the constants were the light exposure, air exposure, type of water, and amount. So the materials I used in doing this experiment were 60 clam shells, 60 crab shells, a soda stream machine, and that's going to be used to carbonate the water so to increase the pH. You're going to need pH strips to make sure that it's at the right level. 35 grams of rock or chlorine salt, a mass scale, plastic wrap, and 4 19-liter or about 5-gallon So for the procedure, you're going to want to make sure you purchase 60 crab and clam shells, and you can either get them from a local pet store or a seafood market, like Wegmans. That's where I got mine from. And next, if the shells are wet, you want to make sure you place them on a tray and put them in a warm oven. And this is going to help dry them out in order to get the most accurate mass reading possible. And this is probably going to take a few hours. So while the shells are drying, you're going to want to get out your 4 or 5 gallon tanks that you bought, and you're going to want to take 2 of them and set them aside and fill them up with about 17 liters of water. And these are going to be a controlled group tank, so you're going to want to label them so you don't get them mixed up. So next, using your rock mix clam salt, you're going to want to measure out 35 grams and pour it into each tank. The clam salt is used to mix the water, so this is going to ensure that the starting pH is around 7.5 to 8.4, which is like normal. So taking out 4 pH test strips, dip one into the water of each tank to measure the pH and ensure that they're all about equal. And now, you just wait until the shells are dry before you move on to the next step. So once your crab and clam shells are completely dry, you want to get out your mass scale. And starting with the clam shells, place them one at a time in scale and record their initial mass. And next, you're going to place 30 crab shells into one control tank and 30 clam shells into the other tank. Next, place the remaining crab shells into one experimental tank and the remaining crab shells into the other experimental tank. So you want to make sure you have like an even amount in each tank to take the test. And then leave the shells in the tank for the next 2 to 3 weeks, and you're just going to kind of watch and observe any changes that you see and report any observations, anything that was significant. So after 2 to 3 weeks, or once the effects of ocean acidification has become noticeable, you're going to want to remove the shells from your tanks and set them out to dry. So again, you might want to dry them in an oven if it's quicker, but you just don't want to change or have a look that'll impact your results. And then once they're completely dry, record the final mass and any other observations that you have. So after taking the final mass of the total number of clam and crab shells and averaging them, I found that the clam shells had a greater average difference in mass than the crab shells. So this means that the clam shells were more greatly affected by the increase of CO2 than the crab shells, and were therefore less resilient. So basically, in the end, I found that my results did not mimic those of the experiment I was trying to recreate, although they were similar. The crab shells did not grow stronger like I thought they would, but the clams did grow weaker. So after reviewing my alternative hypothesis, which said if clam and crab shells are placed into water with an increased pH, then the crab shells will be positively affected and have a heavier final mass, while the clam shells will be negatively affected and have a lighter final mass, I found that it was partially supported. So like I said before, although the clam shells were clearly negatively affected by ocean acidification and did have a lighter final mass after testing, the crab shells were not positively affected and did not have an average heavier final mass. And this is most likely due to not having enough CO2 in the tank for the crab shells to actually become heavier. So my data showed that the average initial mass of the clam shells was 40.1 grams, and the average final mass was 27.9 grams. So as you can see, there's a significant drop in mass. And for the crab shells, the average initial mass was 45 grams, while the average final mass was 40 grams for the experimental tank. So clearly not as much, not as effective as the clam shells. And these results are shown in data table 1, crab initial mass, data table 2, crab final mass, data table 3, clam initial mass, and data table 4, clam final mass. So the results of this experiment were not just due to chance, and the difference in shells did have an impact on the difference in their initial versus final mass, because when I conducted a chi-squared analysis test, my p-value was 0.035, meaning that the data was in fact significant. So the independent variable most likely had an effect on the dependent variable because the clam shells are probably just overall weaker than the crab shells because of the way they were made. whereas the crab shells are more resilient and can withstand, in some cases, thrive off of increased levels of CO2. So, in conclusion, when looking at the effects of ocean acidification on shellfish as a whole, I think it's hard to generalize whether or not they will all be negatively affected by OA or not. So, increased levels of CO2 due to carbon emissions and fossil fuels are just going to increase and get worse as time goes by, meaning that the shelled creatures that are harmed by OA, which I believe to be the majority, are just going to suffer greater harm, whereas those that benefit, the minority, including crustaceans like crabs, are just going to reap greater rewards and build bigger, stronger shells. Overall, I think more research is needed to better understand why some shells, like crustacean shells, are better able to fend off the effects of OA. This will help to gain a better understanding of why OA affects different shells the way it does and prevents shelled organisms from dying off in the future, as OA increases. So, that's my experience. Thank you all for watching, and that's it.